The dimming of lights when appliances such as a refrigerator, air conditioner, or microwave start up, despite each appliance being on its own circuit, usually points to voltage drop within the electrical system. When a substantial appliance initiates its operation, it necessitates a significant inrush of electrical current. This surge in current demand can, in turn, create a momentary decrease in the voltage level along the electrical line. Consequently, if lighting fixtures are connected to the same electrical line, they will exhibit dimming as a result of the voltage reduction. Several factors can contribute to the occurrence of voltage drop. Firstly, the capacity of the wiring itself plays a crucial role. If the wiring is not adequately sized to handle the increased current draw, it will lead to a voltage drop. Secondly, the distance between the electrical panel and the appliance also influences voltage drop, with longer distances resulting in greater voltage drop. Thirdly, loose connections within the wiring can increase resistance, leading to voltage drop. To mitigate voltage drop and prevent the dimming of lights, several measures can be taken. Firstly, employing a surge protector can prove beneficial. A surge protector functions by absorbing the initial surge of current that occurs when an appliance is activated. This absorption helps to prevent an excessive drop in voltage. Secondly, the installation of a voltage regulator can stabilize the voltage on the electrical line. A voltage regulator maintains a consistent voltage level, thereby preventing dimming when appliances start up. Thirdly, upgrading the electrical wiring can address inadequate wiring capacity. If the existing wiring is old or insufficient to meet the demands of modern appliances, replacing it with wiring of a suitable gauge can reduce voltage drop. When dealing with lights dimming during appliance operation, it is essential to seek the expertise of a qualified electrician to conduct a comprehensive inspection of the electrical system. The electrician can accurately identify the underlying cause of the voltage drop and recommend the most appropriate remedies to resolve the issue. An electrician can also look at the main panel and the service entrance to see if there are any issues there that are causing the problem. Firstly, they will check the size of the service entrance conductors to make sure that they are adequate for the load. Secondly, they will check the main breaker to make sure that it is not tripping. Thirdly, they will check the grounding system to make sure that it is properly installed. Voltage drop is an important consideration in electrical systems because it can cause a number of problems. Firstly, it can cause appliances to operate less efficiently. Secondly, it can cause lights to dim. Thirdly, it can damage electrical equipment. There are a number of factors that can contribute to voltage drop. Firstly, the size of the conductors. Secondly, the length of the conductors. Thirdly, the amount of current flowing through the conductors. There are a number of things that can be done to reduce voltage drop. Firstly, use larger conductors. Secondly, shorten the length of the conductors. Thirdly, reduce the amount of current flowing through the conductors. The NEC, or National Electrical Code, provides guidelines for minimizing voltage drop in branch circuits and feeders. While not mandatory, adhering to these recommendations ensures efficient operation and reduces potential issues. For branch circuits, the NEC recommends a maximum voltage drop of 3% at the furthest outlet for power, heating, and lighting loads, or combinations thereof. Additionally, the combined voltage drop on both the feeder and branch circuit should not exceed 5%. For feeders, the NEC recommends a maximum voltage drop of 3%. To calculate voltage drop, several factors must be considered. Firstly, the current flowing through the circuit. Secondly, the length of the circuit. Thirdly, the resistance of the conductors. The formula for calculating voltage drop is voltage drop equals current times resistance. To minimize voltage drop, several strategies can be employed. Firstly, increase the conductor size, which reduces resistance. Secondly, shorten the circuit length, which also reduces resistance. Thirdly, reduce the current flowing through the circuit, which can be achieved by using more efficient appliances or reducing the load. The NEC provides tables that list the voltage drop per amp per foot for different conductor sizes and materials. These tables can be used to calculate the voltage drop for a specific circuit. Maintaining voltage drop within recommended limits is crucial for ensuring proper operation of electrical equipment and preventing potential hazards. Addressing voltage drop issues proactively can improve the efficiency and reliability of electrical systems. An electrician will use several tools to diagnose voltage drop. Firstly, a voltmeter to measure the voltage at different points in the circuit. Secondly, an ammeter to measure the current flowing through the circuit. Thirdly, an ohmmeter to measure the resistance of the conductors. They will also visually inspect the wiring for any signs of damage or loose connections. An electrician will consider several factors when recommending solutions for voltage drop. Firstly, the cost of the solution. Secondly, the complexity of the installation. Thirdly, the impact on the existing electrical system. They will also ensure that all work is performed in accordance with the NEC. Regular maintenance can help prevent voltage drop. Firstly, check for loose connections and tighten them as needed. Secondly, avoid overloading circuits. Thirdly, use energy-efficient appliances and lighting. By following these tips, you can help ensure that your electrical system operates safely and efficiently. Understanding voltage drop and its potential causes is essential for maintaining a safe and efficient electrical system. By taking proactive measures to address voltage drop, you can prevent problems and ensure the reliable operation of electrical equipment. The NEC provides specific guidelines for conductor sizing based on ampacity and voltage drop requirements. These guidelines ensure that conductors are adequately sized to handle the intended load without excessive voltage drop. For example, NEC Table 310.15. B16 provides ampacity ratings for various conductor sizes based on insulation type and installation conditions. When selecting conductors, it's crucial to consider the ambient temperature and derating factors specified in the NEC to ensure that the conductors can safely carry the intended current. Additionally, the NEC provides guidelines for calculating voltage drop in Chapter 9, which includes formulas and tables for determining voltage drop based on conductor size, length, and current. Properly sizing conductors and calculating voltage drop are essential steps in designing and installing electrical systems that meet safety and performance requirements. Ignoring voltage drop can lead to several consequences. Firstly, reduced equipment performance. Secondly, increased energy consumption. Thirdly, overheating of conductors. Fourthly, premature equipment failure. Therefore, it's crucial to address voltage drop issues proactively to prevent these problems. Surge protectors work by diverting excess voltage away from sensitive electronic devices. They typically contain metal oxide varistors, or MOVs, that clamp the voltage to a safe level. When a surge occurs, the MOV conducts the excess current to ground, protecting the connected devices. Surge protectors are rated by their ability to absorb energy, measured in joules. A high joule rating indicates greater protection. It's important to choose surge protectors that meet UL 1449 standards for safety and performance. Surge protectors should be installed at the point of entry of electrical service and at individual outlets to provide comprehensive protection. Voltage regulators maintain a constant voltage output despite variations in input voltage or load current. They use electronic circuits to regulate the voltage to a specific level. Voltage regulators are commonly used in sensitive electronic equipment to ensure stable operation. There are different types of voltage regulators, including linear regulators and switching regulators. Linear regulators are simple and inexpensive but less efficient. Switching regulators are more complex and expensive but offer higher efficiency. The choice of voltage regulator depends on the specific application requirements. Electrical wiring upgrades involve replacing old or inadequate wiring with new wiring that meets current standards. This may include replacing aluminum wiring with copper wiring, increasing the conductor size, or adding dedicated circuits for high-demand appliances. Electrical wiring upgrades should be performed by a qualified electrician to ensure safety and compliance with the NEC. Before starting an electrical wiring upgrade, it's important to obtain the necessary permits and inspections from the local authorities. Electrical wiring upgrades can improve the safety and reliability of the electrical system and prevent voltage drop issues. When inspecting an electrical system for voltage drop, an electrician will check several key components. Firstly, the service entrance conductors. Secondly, the main panel. Thirdly, the branch circuits. Fourthly, the grounding system. They will use a variety of tools to measure voltage, current, and resistance and identify any potential problems. An electrician will also look for signs of damage or deterioration, such as cracked insulation, loose connections, or corrosion. The inspection process may involve visual inspection, testing, and measurement to ensure that the electrical system meets safety and performance requirements. Regular electrical inspections can help identify potential problems before they become serious and prevent costly repairs. The grounding system is an important safety feature of an electrical system. It provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system should be properly installed and maintained to ensure its effectiveness. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for connecting grounding conductors. A properly installed grounding system can protect people from electrical shock and prevent damage to electrical equipment. Loose connections can cause voltage drop and other electrical problems. Loose connections increase resistance, which reduces current flow and can cause overheating. Loose connections should be tightened to ensure proper electrical contact. An electrician will use a torque wrench to tighten connections to the proper specifications. Regular maintenance can help prevent loose connections and other electrical problems. Overloaded circuits can cause voltage drop and other electrical problems. An overloaded circuit occurs when the current draw exceeds the capacity of the circuit breaker or wiring. Overloaded circuits can cause overheating, which can lead to fire. It's important to avoid overloading circuits by using fewer appliances or using appliances with low power consumption. An electrician can install additional circuits to distribute the load and prevent overloading. Energy-efficient appliances and lighting can reduce the current draw on electrical circuits and prevent voltage drop. Energy-efficient appliances use less electricity to perform the same function as standard appliances. Energy-efficient lighting, such as LED bulbs, uses less electricity and lasts longer than incandescent bulbs. Using energy-efficient appliances and lighting can save money on electricity bills and reduce the strain on the electrical system. Understanding electrical circuits is essential for troubleshooting voltage drop. An electrical circuit is a closed loop that allows current to flow from a power source to a load and back. A simple electrical circuit consists of a power source, conductors, a load, and a switch. The power source provides the voltage that drives the current through the circuit. The conductors provide a path for the current to flow. The load consumes the electrical energy and performs a function. The switch controls the flow of current in the circuit. Troubleshooting voltage drop involves identifying the cause of the voltage drop and taking corrective action. The troubleshooting process may involve visual inspection, testing, and measurement to isolate the problem. Once the problem is identified, it can be corrected by replacing damaged components, tightening loose connections, or upgrading the wiring. Proper troubleshooting requires a thorough understanding of electrical circuits and the tools used to measure voltage, current, and resistance. The NEC provides guidelines for selecting and installing electrical equipment to prevent voltage drop. These guidelines cover conductor sizing, overcurrent protection, and grounding requirements. Following the NEC guidelines ensures that electrical equipment is installed safely and performs as intended. The NEC is updated every 3 years to reflect the latest technology and safety standards. It's important to stay up to date with the latest NEC requirements to ensure compliance. Electrical safety is paramount when working with electrical systems. Always to energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment. If you are not qualified to work on electrical systems, hire a licensed electrician. Electrical shock can be fatal. Always follow safety precautions when working with electricity. Regular electrical maintenance can prevent voltage drop and other electrical problems. Regular maintenance includes checking for loose connections, inspecting wiring for damage, and testing the grounding system. Regular maintenance can identify potential problems before they become serious and prevent costly repairs. A qualified electrician can perform regular electrical maintenance and ensure that the electrical system is operating safely and efficiently. Understanding electrical codes and standards is essential for ensuring electrical safety and preventing voltage drop. Electrical codes and standards provide guidelines for the design, installation, and maintenance of electrical systems. Compliance with electrical codes and standards is mandatory in most jurisdictions. Failure to comply with electrical codes and standards can result in fines and other penalties. Staying up to date with the latest electrical codes and standards is essential for electrical professionals. Proper electrical design can minimize voltage drop. Proper electrical design involves selecting the appropriate conductor sizes, minimizing circuit lengths, and balancing loads. Proper electrical design can improve the efficiency and reliability of the electrical system. A qualified electrical engineer can perform proper electrical design and ensure that the electrical system meets the needs of the application. Voltage drop can also be caused by harmonics in the electrical system. Harmonics are distortion of the voltage and current waveforms. Harmonics can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause overheating of conductors and equipment and increase voltage drop. Harmonic filters can be used to reduce harmonics in the electrical system. Transient voltage surges can also cause voltage drop. Transient voltage surges are sudden increases in voltage that can damage electrical equipment. Transient voltage surges can be caused by lightning strikes, power outages, and switching of electrical loads. Surge protectors can be used to protect electrical equipment from transient voltage surges. Power factor correction can reduce voltage drop. Power factor is a measure of how efficiently electrical power is used. A low power factor indicates that the electrical system is not using power efficiently. Power factor correction can improve the power factor and reduce voltage drop. Capacitors are typically used for power factor correction. Understanding the relationship between voltage, current, and resistance is essential for troubleshooting voltage drop. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. Ohm's law states that voltage equals current times resistance. By measuring voltage, current, and resistance, it is possible to identify the cause of voltage drop. The type of load can also affect voltage drop. Resistive loads, such as heaters and incandescent lamps, draw a constant current. Inductive loads, such as motors and transformers, draw a current that lags the voltage. Capacitive loads, such as capacitors, draw a current that leads the voltage. The type of load can affect the amount of voltage drop in the circuit. Using appropriate wiring methods can minimize voltage drop. Wiring methods include conduit cable and wireways. The choice of wiring method depends on the application and the environment. The NEC specifies the requirements for wiring methods. Proper wiring methods can protect conductors from damage and minimize voltage drop.